All right, example 3 involves a motorbike that is going 60 miles an hour on a level road. So here we have a level road, and I've got a motorbike. So here we go. And it is zooming along, and it comes to a stop. So the first question we ask is, where did the energy go? It had kinetic energy, but it came to a stop, so the kinetic energy was gone. Okay? So something removed mechanical energy from the system, and the answer is, it was the brakes. They converted the energy to heat. All right, and we got to find out how much work is done by the brakes. So we are going to call the level road y equals 0. So that means that the initial height of the motorbike is 0 meters, and the final height of the motorbike is 0 meters. The initial velocity of the motorbike is 60 miles an hour, which we're going to convert to meters per second. And if we convert 60 miles an hour to meters per second, we are going to get 60 miles an hour. We multiply it by 1609 to get meters per mile, and then we'll divide by 3600, and we'll get 26.8. So the initial velocity is actually 26.8 meters per second. The final velocity is 0 because it comes to a rest. We are told the mass of the motorbike is 500 kilograms, and we are asking for the work. How much energy was transferred out of this system in order to get it to stop? So we are going to apply our principle of energy conservation, which says the mechanical energy at the end of the problem is equal to what we start with plus the work. When we write out what this means for this problem, we get 1/2 mv final squared plus mgh final. That's the final kinetic and potential energy. That equals 1/2 m the initial velocity squared plus mg times the initial height plus the work. Now, because the final height and initial height are 0, potential energy doesn't really come into play in this problem. The potential energy doesn't change. Also, because the final velocity is 0, this term goes away. And our plan is to solve what remains for the work, the energy transferred into or out of the system. Okay? So, to find the work, it's pretty easy. We just get the work equals minus 1/2 m times the initial velocity squared. Okay? M is 500. The initial velocity is 26.8 squared times 1/2. And when you do that, I think it's pretty easy to get to the answer by plugging in the numbers. You can show that the answer is negative 180,000 joules. So it's negative because energy was removed. Remember, W is negative if we remove energy. It's positive if we add energy. And so we removed 180,000 joules of energy from this motorbike. Okay, so that was the work that was done.